So security. So I am not a cryptographer and not a security expert, but I do know some very good ones, and I think they rubbed off on me. And I want to discuss a couple topics about security in Swarm that seem to have come up in the last few days, at least in my mind. So when reading the Swarm Orange papers, one thing that I felt I needed is a better encapsulation of the pieces, right? Because the way it's described, there's a routing layer, some sort of routing layer that was discussed the first day, right? Each of us have an address, and we know how to find, and every piece of content has an address, and these are stored in some network with some topology. So there's a routing structure. On top of it, there is a file storage structure, or let's call it file storage. File storage. So here there's the pyramid, the error correction, all of those things. Here there's the addresses, address assignment, stuff like that. And then on top of this, there's the incentives that make sure that, that stuff actually runs smoothly and doesn't get lost, right? My issue is that when trying, I want to have provable security for these things. I feel it's not enough to just know that things should probably be okay and that they're engineered to work. I want to know that things are totally safe and no one can mess with the system, because I think that messing with the system is expensive politically for Ethereum. Once things have vulnerabilities, it's not only that you lost a file and the file was insured for $1,000 and you get the $1,000. It's dangerous for the project or for the name, for the Ethereum name, if things go missing, and especially if an attacker can cause things to go missing at will. So even if they have to invest a bunch of effort to do that. So I want to start proving security, and to prove security, I need to understand how these pieces interact. And what I would like to either do myself or get some help or have magically happen is for each of these pieces to be encapsulated nicely by a sort of API or spec that says, listen, from the file storage layer, here's what you can expect from the file storage layer. It gets this input, it serves an output. We don't even need the details about how it does it. Here are what you can expect from it. This is the efficiency. This is the security guarantee, and so on. And as an example, I'm going to describe a few ideas about what can be expected from the routing layer, some preliminary ideas. And I feel that this is the way to design security, to ensure security by design, partly because think about the original Bitcoin implementation, right? There was a reference implementation that wasn't probably the most efficient thing ever, and but what it gave is a way to measure your progress. It gave an implementation that you say, here are the properties that you should be expecting from any implementation in the future. It should match this, right? You have a reference, and you go from there. A spec or a security design works a bit like that, right? We say, first of all, how you should think about the routing layer. For example, the way we always think about it, but is never kind of stated, is that each address is random, right? We say it's a hash of something, of the public key, and therefore it should feel to us kind of random. We all use this knowledge that it's random, but we never quite say it. The reason we don't say it is because we don't have anything to prove based on it, because we don't write proofs, and because it's not quite right, because it's not random, because people can engineer their addresses, and there's a whole thing that we discussed 2 days ago, right? So there's a way to, the cryptography scene, especially theoretical cryptographers, found a way to reason about this stuff. They say, here is how to think about this in an ideal routing layer. All addresses are random, completely random. And in the real world, we say any routing layer that we replace, this should be totally modular, right? Any routing layer that you replace it with should have the following property. For example, you should be able to get random addresses and pay $1 to get each one, or pay something. So for example, you pay $1 per address, per random address. And by random, we mean some technical thing like how it's indistinguishable or unbreakable, or you can't plan it, or it doesn't have any, it has these really great random properties. And then the layer above it can come and say, I don't know how this is implemented, but I got a guarantee. So let me prove things, let me build based on this guarantee and prove things based on it. For example, if the addresses are random, then no one can stalk me by sitting close to me unless they spend $1 million, and let's now start proving security properties of this. And this goes all the way up. Every one of these layers would be modular, and maybe we'd start. One nice thing that happens with Bitcoin is that people write their own. People write their own very, very lightweight, easy Bitcoin client and or implementation, and it's not efficient and it's terrible, but they have hands-on information, knowledge about how to do this. They understand the system this way. I want to write my own routing layer, but right now I don't know how to because I don't have an abstraction. I don't know what the input and output should be. And that's what I feel would help us kind of ensure security, ensure people understand these things, and so on. One more comment about, for example, the routing layer. So I would love to avoid security by obscurity. And the way to do this is to assume that everyone knows everything, unless what we can specifically prove that they don't know. So for example, I want to ensure that any attacker or any player in the system, I want to assume that they know everyone's addresses, they know who has which file, who uploaded it, who has which chunk, what the chunk's addresses are, who stores each chunk, and so on. That's my security assumption. This is how I model an attacker. And then I want to say, to start taking pieces of knowledge away. I want to say, listen, I am going to encrypt a certain piece of information so that the attacker doesn't know it. But I want to assume that all attackers know everything except what we prove that they don't know, and start building security guarantees from there.